Today I'm going to tell you about one of the most complicated problems in software development. It is the problem of handling dates and times. If you think that it's not true, just keep watching and think again after the presentation. But today is today is May 4th, so May the 4th be with you guys. Here is our agenda. First things first, I will give you a brief introduction of how people are using date and time in real life and why it's important. Then I will talk about the system that is developed to put dates in order. The system is a calendar. After that, I will show you some problems that can happen if software engineers are not careful with the calendar. Next, the time zones. What is it? Why do we have them? And what is not a time zone? Some common problems in software development are related to time zones. And the topic daylight saving time. What is it and why is it the pain? So let's start from the definition of a year. A year is a time taken by the Earth to make one turn around the Sun. You can see a simple illustration of this on the left. However, in reality, the process looks more like illustration on the right. Why year is important for us? Because of seasons of the year. At different times of the year, the sunlight angle to the surface of the Earth is different. Also, the Sunday period and the average temperature differ significantly. This effect has a huge impact on activities of people around the world, mostly agricultural. That is the reason why year is important. The next physical phenomenon, which is also very important for us, is a day. The day is a time period of the full rotation of Earth with respect to the Sun. And it is not the time of the full rotation of Earth in space. The difference is that during a day, a year also does a movement around the Sun, which is about 0.98 degrees. And this value also influences the definition of the day. So why day is important for us? Because we cannot see well at night. And the majority of people are sleeping at night. All the activities are concentrated in daylight hours of the day. So we have two phenomena related to time, and these are important for us. Somehow we need to have a system that can handle both years and days all together. And this system is called the calendar. People were trying to create such system in different parts of our planet at different times. There are many different types of calendars, and they were used in some cases in parallel. The most common calendar nowadays is a Gregorian calendar. As many other calendars, it has definition of such thing as a month, which is related to the rotation of a moon around the Earth, and a week, which is more cultural thing than astrophysical. And we just don't want to work every single day. We want to have day offs. And we can trace the roots of a week, of 7 days week, back to the Babylonians, who were using this week in their calendar. Currently, the Gregorian calendar is a standard de facto across the world. The global economy and money want to have standardization. So you either go with the global economy and you using the global standard, or you're out of global economy. So the choice is obvious. So Gregorian calendar is a system that looks like this. There is a year which consists of 12 months and 365, or in some cases 66 days. In February, we do have an additional day sometimes, because we cannot divide the period of a year to the period of the day without the reminder. The calendar defines such a day as a leap day. And the year when we do have such day is a leap year. This sometimes is a little bit tricky in the calendar. Can you say the rule without Googling it? What years do we have a leap year? I can give you a few seconds to think, and we will check it if you know this well or not. So the rule looks like this. So if year can be divided by 4, it is so if it's not divided by 4, it's common year. If it is, but it's not divided by 100, is a leap year. If it is, if it does, and it's not divided evenly by 400s, it's a common year, and otherwise it is leap year. So if we talk the technical language, there is a system that has definition of rules and boundaries for entities like year, month, and day. So in general, a day can have a number from 1 to 20, 28, 29, 30, and 31. And the month is an entity that can have a number from 1 to 12. And the year can just have positive number. It is an interesting fact that there was no year 0. The current age started from year 1 because there was no 0 at that time. People were using Roman numbers, which don't have definition of 0. And you can imagine what are problems related to the calendar in software. These problems are happening when software engineers do not follow these relatively simple rules and boundaries. If you don't follow the rules, you're out of boundaries. And if you do, you will probably get out of range exception, as you have with arrays, for example, like this. So here are some samples of what can happen. In 2008, in December, Zoom players were disabled because of how they are handling the leap year 2008, and the problem was automatically resolved in January next year. In 2010, some PlayStation 3 devices recognize this year as a leap year. In 2012, some Azure services were down because of incorrect calculation of TLS certificate valid to property. Here are some examples of such defects. For example, in PHP, the function create from format skipped February 29 if the day of the year is placed before the year. And that problem remained unfixed from 2012 until 2020. How not to let these defects happen? You should never manipulate dates using arithmetical operations. You should always use libraries that you trust. Never reinvent the wheel. And be careful, because the rules work different from what you could expect from simple mathematics. For example, if you add 1 month to the date and then remove it, you will not get the same result as you had before. Also, when you work with something like monthly subscription, and it's important to renew the subscription the exact same day of the month, then you should use the original subscription start date and not the last one. Here is the difference. If you take the previous date and add 1 month, you will eventually be stuck with the number 2028. So you should think which case is better for you, and you should know what you're doing. And if it's not too complex for you, here is another topic: time zones. The time zone is a system that reflects sunlight movement during the day on the surface of the Earth. In order to keep the clock across the world synchronized to the sunlight, people are using meridians to shift the clock hours. There is a prime meridian called Greenwich, which is a basis for the system. All other meridians have offsets in hours in plus and minus directions. This is, however, just the definition of geographical time zone. An administrative time zone, on the other hand, is a reflection of political state of the world to that system. Each country or administrative area decides how to adjust the system in order to make it more useful inside the country. These individual changes then become a part of global time zone system. Here is how time zones look like at the scale of the world. But the previous screen was more for managers and users. This screen for engineers. Here is how you guys should see time zones on a map. An interesting side effect of that political decisions is that in some places, time zones are thin enough for you to celebrate New Year twice or more times a year. But in some cases, administrative decisions result in an interesting effect. Here you can see 2 islands in Pacific Ocean. Kiribati Island has offset plus 14 hours. And there is a Becker Island, which has a time offset minus 12 hours. The difference between these 2 islands is about 2,000 kilometers, and they have 26-hour difference. So when Kiribati Island is January 1st, Baker Island is December 30. So there is a difference between them more than 1 day. Let's give a definition of a time zone. You should know that there is no international standard of time zone, but I will touch this topic later. Let's define it as it should define a current time UTC offset. The time zones are set and can be changed by the governments. They have some string identifier. They include rules for changing local time clock, for example, change to DST and back. And so they also include history of changing these rules for local clocks. Let's briefly go through some fallacies about time zones. So fallacy number 1. A time zone is a numeric offset of from UTC. And this is not true because of the definition we stated before. And more than that, sometimes some time zones can have the same UTC offset in some periods of time. Fallacy number 2. Time zone names and abbreviations are unique. This is not true because many different time zones can have same names and abbreviations. Here are some examples. Here is an example of what can go wrong if you use time zone abbreviation in your software. This happened to me personally when I was attending a company interview. 2 times I joined a meeting, but nobody was on it. And 2 times after that, I got email from recruiter who was complaining about me not being on the interview. In invitation email, there was a time zone abbreviation IST, which could mean different time zones. And there was no automatic calendar invitation for the interview, which can handle this problem automatically. So you should try to avoid using time zone abbreviation as much as you can. And if in some cases abbreviation is appropriate solution for you just for user interface, you should never use it inside the software because there is no way to recover time zone identifier from that abbreviation. Next fallacy. In the USA, if I know what state the person is in, I can determine their time zone. This is not true because, for example, here is a map of South Dakota. Left part of it uses one time zone and the other uses another one. As this is not the single case. Next fallacy. There are only 24 possible offsets since they are 1 hour increments. Here is an example. Here is an Australia. They have time zones that have UTC offsets plus 9:30, plus 10:30, and even plus 8:45. And of course, there is a Kiribati Island which had offset UTC plus 14. Next fallacy. Time zone will never change. So if I only have, I only have to think about it when I first build my application. This is not true because time zones are created by people and people like to change rules. Usually this change is known in advance, but there were some cases when decision was made 2 hours before the change. So you should always keep your time zone data updated in your application. Here is an interesting example. There is an island in Pacific Ocean called Samoa. And in December 2011, they changed the UTC offset from -10 to +14. So the entire day, December 30, was just gone. There was no December 30, 2011 on Samoa. Let's talk about the thing called perspective. Inside the software, the date and time can mean different things. It can mean UTC. It can mean local time on computer the program is running on. And it can be unidentified or unknown. In .NET, these three things are known as date kinds. And understanding of these three possibilities is very important. Have you faced an issue in software when the date was shifted one day backward just because of time zones? I've seen these problems many times. Here are some examples of how to work with date kind in .NET. When you create new datetime structure without specifying its kind, it's always unknown or unspecified because you just don't tell the program what date is it. If you then want to make sure it is UTC, you will try to use to universal time method. But in this case, the date will be converted from original one as it was in local time. So when you convert dates and times from one value to another, you need to know exactly how your functions and libraries are working. As a result, you can lose a couple of hours. And when you convert the date back to string, showing only years, months, and days, you can just lose one day. Here is how it should do, how you should do this in .NET. You should not use to universal time. Instead, you should specify kind for date. I'm sure that in different programming language, there are similar problems. Here are some examples of how you can convert date from one time zone to another. This can be useful if your software explicitly asks the user about user's time zone. For example, somewhere in user cabinet or settings. And of course, when you work with internet application, you should keep in mind that the client you are working with can be in a different time zone, not the same one where the server is located. So local on client computer is not the same as local on the server. So if you transmit the date through the network, you must keep control over what date is it. In order to transmit the date through the network, I highly recommend you to use this ISO standard because it is supported by, I think, all programming languages and libraries and frameworks. And for example, here, please keep in mind that this date does not have any time zone identifier. There is no time zone information here because it only contains UTC offset. You cannot recover time zone information from it. So we already discussed that sometimes the government can change UTC offset in their time zone. But let's talk about cases when UTC offset changes more often. Let's talk about daylight saving time, or DST. Daylight saving time is used to save energy and make better use of daylight. It was used first time in Canada in the year 1908. One of advantages of daylight saving time is longer summer evenings. So usually it looks like this. In the fall, we move the clock backwards. In the spring, we move the clock forward. But if it's as simple as that, maybe people have some standards of when and how to do this change. Let's try to guess. Time changes are made the same time. This is false. As you can see, different countries adjust the clock the different time of day. Okay. Maybe then time changes are made the same day of year. And it's also false. Here is a time change schedule for Germany and USA. Okay, maybe at least a specific country changes the time the same day of a year. Also false. Here is a DST schedule for France. But at least a specific country changes the time on its entire territory. And it's also false. Here is the US. One state called Arizona does not change the time at all. And even more, there are places in Arizona that actually use DST. But the shape of these locations is not straight. As you can see, there are some areas which decided not to use DST. You say, okay, but at least everybody switches exactly for 1 hour. And this is also not true. Here is an island called Lord Howe, which is near Australia, and they do switch only 30 minutes. But this one should be simple. Time changes happen twice a year. Well, not true. Here is Egypt in 2010. They decided to switch time 4 times of year, and this is related to Ramadan. And then Morocco said, nice idea. but after they tried it, they switched back to 2 times. But if you go and try to see what time a year they do switch, you will see that Morocco changes by different schedule. They change time both times in spring. So, and what is more interesting is that they change backward first and then forward, because usually we do vice versa. So here is a thing. It is called DST change here on the website. This is one of most interesting websites about time and date and time zones. It is called timeanddate.com. It is stated that this is DST change, but this change is related to Ramadan. It's not related to DST. So actually, Morocco does not have DST. A specific country has consistent rules. Also not true. Here is a history of decisions for Brazil. Brazil changed the decision of using or not using DST 7 times. And also, they changed the time of day when this change happens. Here is more or less current state of countries which are using DST. This is primarily USA and Europe. But last year, USA had plans to stay on daylight saving time, but these plans are not implemented this year. What problems can you have? Imagine you have a service that plans events across the world. You have a user's time zone because you're smart. The user sends a date of an event to you. You take the data, assuming this is user's time zone data, and you're trying to convert it to UTC. And you will get this exception because this date simply does not exist in user's time zone because of time switch. If you don't get this error or exception in your programming language or framework, well, that's even worse because your program works incorrectly. Okay, let's do it more interesting. You're not interested in time initially. You're only interested in date. And you have a service which deals with user subscriptions. And the important requirement is that when user creates subscription, this subscription needs to be renewed exactly same time, exactly at midnight for user time zone. And you can face this issue in Brazil because sometimes they just don't have midnight. They didn't have it. Right now they have, but in 2019 they did not have it. So even if you explicitly don't focus on like time after midnight, during the midnight you can get this exception because midnight does not exist. Another common issue is how software engineers are measuring intervals in time. You should not use timestamps and calculate the difference between them, because depending on the time zone, you can get negative result. Or your result can be adjusted forward by time change. So you should use only tools exactly for that purpose. Here is an examples for .NET. You can say, I will just use UTC everywhere, and I will not have problems like this. Well, this also might not help you. Imagine you're creating a service which is about local events. That means event should happen at 2 p.m. local time somewhere in the future. What you do is you just convert time to UTC and save it in the database, and you also save user's time zone. So you think that you will be able to recover user's local time from time zone information and the date in UTC. Somewhere closer to UTC, you can take it and try to convert it back. And the logic can be broken by change in time zone rules. For example, politician decided not to use daylight saving time anymore. If that happened, you will use different rules when you save the value to the database and when you read it back. As a result, you will get incorrect local time. So here is an example of what we have seen previously. So for all past events and the present, you can use UTC and it should work well. If you will work with future, you should use local time if it does matter for you, and you should also save user's time zone. So you should not use UTC plus time zone. You should use local time in some time zone plus that time zone. And again, there is no time zone information in this date. This looks complicated and looks like you cannot manage all these changes in time zones yourself. And in most scenarios, you should not. Your operation system does this for you if you patch it regularly. Operation system updates also include time zone database updates. So what time zone databases exist and how to use them? The first you should know about is the IANA time zone database, also known as Olson database or TZDB or TZ or Time Info. It is accurate since 1970s, and it also has history of time zone changes back to the history down to 1800s. The identifier in database looks like area/location. And for example, America/New York. Usually identifier has 2 pieces, but sometimes it has 3. There is an identifier America Sao Paulo, and it can be it can be a little bit confusing because Sao Paulo is in Brazil, it's not in USA. But America here does not mean like a country, it means part of the world. The same thing is here, like Europe, Moscow, Europe, London. There is an area Asia, there is a separate area Australia. So usually it's part of the world/city. This database is maintained by a community of historians and developers. It is natively supported by programming languages such as Java and PHP. It is supported using additional libraries for Python, C++, Perl, .NET, and JavaScript. If we are talking about databases, it is natively supported by Oracle and PostgreSQL. If you have MySQL or RavenDB, you can install some add-on which allows you to use this database. This database is also natively supported by operating systems like Linux or Unix, macOS, iOS, and Android, but not for Windows. For Windows, we do have our own separate time zone database maintained by Microsoft. It is built in Windows Registry. It is less accurate than time zone IANA, and sometimes it has strange identifiers. For example, you can see there is an identifier Eastern Standard Time, which stands for EST and EDT. It has separate identifier Mountain Standard Time and US Mountain Standard Time. First one is for Mountain Time except Arizona, and second is just for Arizona. There is a identifier Romance Standard Time for Paris. So identifier is less straight than identifier in IANA. Important note for engineers. When I was working on this presentation, I changed my mental model about what time zone really is. It is just set of rules about the local time and history of this rules back in the past. If two locations have same rules at present and the same history of rules in the past, they can have the same time zone. If two locations have any difference in rules in present or in the past, then these locations are not in the same time zone. If changes in rules applied to a part of location that had common time zone in the past, then time zone splits into different time zones from that point of time. And time zone database will reflect that change by introducing new time zone identifier. You might not face this fact as a user, but it's important for understanding for software engineers. Here is an example. If you try to look for time zones about Toronto and New York, you can think that they are in same time zone. But in IANA database, they have different identifiers, which means they have different time zones. Microsoft time zone database is not so accurate. So according to Microsoft time zone database, they are located in the same time zone. The difference is that IANA time zone also reflects some history of changes during Second World War. And Microsoft time zone just does not have this. And I would like to also include one more thing here. There is a thing called leap second. It is an extra second, which is added last day of June or in December to keep the time of the day synchronized with Earth rotation relatively to the sun, because the rotation is slowly decreasing in speed. And we had 37 leap seconds in history right now. And there are ways in software to reflect this leap second. Usually, it is implemented as additional second for a minute. And that's it from my side. I'm ready to answer questions.